I would like to start with a real-world story. A project that started on the green field with a very small team. I was product owner of a team of 4 developers and 1 UX designer. Both the designs and the implementation started on the green field, meaning broad guidelines like the brand colors of the company existed, but this was the very front end that was developed at that client. Basically, the UX and UI design was done from scratch right along with the implementation. Collaboration between designers and developers was close. We had regular refinements together. We discussed all the screens in detail. Designers joined the daily meeting with the developers to answer questions. We used Material UI, a rich component library for React that comes batteries included with a vast range of components. So we mostly just had to apply the company branding, the styling as a theme. In short, we followed every best practice in the book, or so we thought. After about 2 years, the designers wanted to update a few parts of the design that they felt were not adequate anymore. One of them was the button design. The client had grown a lot since then, and so had the code base. We had now multiple teams working on the front end, a full team of designers, and hundreds of screens. The styling here is fictional, of course, but the change was similarly complex, or rather similarly simple. Basically, they switched out the styling of the secondary button to make it stand out a little less compared to the primary or call to action button. So how long do you think this change like this should take?
18 months. 40 scoring points.
Excellent. So this took actually 2 sprints to finish, multiple weeks. And for me as a product owner, this was really hard to believe. Like, how can it take that long? And we did everything by the book, right? So how can we be so wrong here? Well, let's investigate together where we went wrong and how this seemingly small change could turn out to be so complex. Let's have a look at how our buttons were implemented. Is there maybe someone who can already spot the problem? Yeah?
You did not say this is a primary button and this is a secondary button. You described how it should look like.
Exactly, yeah. So that's the root cause. All of our buttons were styled individually. There was no generic secondary button component. Instead, we just applied the primary color, actually, because of a weird switch between what is primary and secondary in a brand color versus on a button. But yeah, we basically just styled every secondary button to look like the button in the designs. So in order to change the design, we had to look for every single instance of such a button. We had to, in every component, on every screen. Sometimes you have line breaks in between there. Sometimes you don't. Sometimes these properties, these colors, are set dynamically. So it took days to adapt all the instances we could find quickly, and then weeks for really checking all the screens and making sure that there are no more instances of the old styling. Now, of course, this was a mistake, and one that we made very early on and never corrected because there was no reason for it until it came back to bite us. Instead, what we should have done, we should have created wrappers for the primary and secondary buttons that follow the styling for these variants. Then the change would have been very easy, just a single line, basically. But the reason for this mistake is much deeper. It's not just bad front-end implementation practices, but rather, I think it's really rooted in the way designers and developers communicated in that project. Collaboration between designers and developers is mainly governed by a process called the handover. The goal is to make sure that developers know what and how to implement things. This is how our handover process looked like. And I would say this is a fairly typical process. I've seen that in other projects as well. So designers use Figma or similar tools to create components and assemble them to full-screen designs. Figma is a design-focused tool that allows creating components, screens, up to full click dummies. And it also has built-in tooling for the handover process. There is a dedicated developer mode where you can take break the screens down into components, and you see the spacing, the tree, up to CSS properties that you actually can copy-paste. The developers then take those screens and implement them. And as I said, we did work really closely. I've heard from other designers that they sometimes produce designs and then wait for half a year until those designs are implemented. That wasn't the case for us. We really had very short implementation cycles, regular refinements with designers and developers to discuss the details of the screens. And the designers, of course, did review the finished implementation. The screens the developers got from the designers were designed to be pixel perfect. So really to the point where you can basically use the input screens for visual testing. So we were fairly confident, but we did get really wrong. And here's the point. For the designers, it was very clear that there were only these two types of buttons, and that all secondary buttons were just instances of the same design. So for the designers, this was a generic component, and the change was a very simple change for the designers. But our handover was not on the level of buttons. It was on the level of finished screens. And all the information about building blocks and generic components and primary and secondary buttons got lost in those pixel-perfect screens. Developers had to reconstruct this knowledge. And that was based on, well, best guesses. And in our case, the developers just guessed wrong. The implementation did match the screens visually, but we didn't have any guardrails in place that the implementation also matches the design structurally. So this talk is about the techniques and the technology or tools you can use to avoid this mistake. The first part is about the techniques. Like I said before, UX and UI designers structure their work in terms of reusable components. And as developers, well, we actually tend to do the same thing. So the idea is to find a common language between designers and developers, a common structure, so that we have the same mental model when we talk about these components and can move beyond the only talking about full screens. Atomic design was popularized about 10 years ago in a book by Brad Frost. The idea of such a hierarchy, however, is a lot older, but the book established a terminology that has stuck since then. The details have evolved a bit, but the idea is still very much valid. And the book is available online. You can really read it here on Brad Frost's website. Atomic design is a fairly straightforward version of such a common language. We have a hierarchy of building blocks from the smallest subatomic particles to the finished screens. Atomic design is not the only way of structuring design work, and nowadays designers tend to work with so-called design systems that are a lot more comprehensive than that, and also include style guides and pattern libraries and an overall design language. But even a design system relies on the same building blocks, and the same common language can be applied. We start with design tokens, the subatomic particles, basically, the fabric that our components are made of. So that can be typographical tokens, like font family, font sizes, font weights. Tokens for theme colors, like the primary and secondary color, or semantic colors, like warning, info, and error. And we've learned that you shouldn't rely on color only, but of course, color still plays a very important role in conveying information. And other visual tokens, like spacing, shadows, borders, radiuses. Together, they form the overall theme of a design. These tokens are reusable. We can now refer to the primary color instead of a hex code in the designs, in the implementation, and in conversations. And by the way, design tokens were originally not included in the hierarchy by Brad Frost. So I kind of added them here, but I see them commonly mentioned in the context, and I think it's definitely necessary to include them explicitly. Next up are atoms, our smallest indivisible UI elements. These can be things like buttons, text fields, cards. These are the generic building blocks for everything else and can be reused across the entire interface, user interface. They come pre-styled, usually with variants, like, for example, our primary and secondary buttons, and potentially different states. For example, when I go to that text, click in that text field and enter something, then the text field will move into a different state. The button has focused and pressed states, hover and pressed states. However, the content of those components is controlled from the outside, like the label of the button, the label of the text field, etc. We can then compose those atoms into molecules, small functional building blocks that are cohesive, and also start adding some business logic and behavior. A form field with validation, for example, a button group, drop-down menus. Molecules are a bit more complex. They can have logic, like the drop-down logic that shows and hides the menu when you click it, and can, for example, change the button based on the selected item, or showing an error message when the text field is empty and resetting the error when the user enters something. But these are still very generic and reusable. Despite them having internal logic, they are mostly controlled from the outside. Now we can combine atoms and molecules into organisms, distinct sections of the user interface that can start having complex state and behavior. A full sign-up form, for example, sidebar menus, dialogues, tables with filters, shopping carts. These organisms are not generic anymore. They often directly represent a specific feature in the implementation. They can handle complex logic, complex state, complex behavior. So this is the first level that is actually mostly self-controlled. Organisms manage their own state and their own things like backend connections. And finally, these organisms are composed to entire pages, complete layouts, that's the templates, with all the behavior and interaction. So, as a developer, why should I care about atomic design? Well, atomic design provides a shared vocabulary. When designers create or change components, they use these same tools. They know exactly what level in this hierarchy a component belongs to, and whether it's a common rule, like design tokens, a generic building blocks, like an atom or molecule, or a specific purpose-built structure, like an organism, template, or page. In the communication between developers and designers. We can now use these terms and make sure that our implementation does not only match visually, but also respects the structure of the designs. The button in our original example were not generic components. They were ad hoc structures that just happened to look like the designs. Whereas the generic Acme button atom is just as generic and reusable as its design is. And most importantly, it can change in the same way as the design changes. Now, you might say this is obvious, and in hindsight, of course, it is. But over the years, I've actually seen many front ends that follow the pattern on the left. Full screen handovers completely omit the hierarchy information, so it's really easy to fall into that trap of treating everything as specific. So it does make sense to make these patterns explicit. And atomic design is just one method of formalizing this conversation. Now, going back to our handover process, we introduce a common language to talk not just about the screens, but also the building blocks that these screens are composed of. We as developers now can understand a lot better the designer's intent and their way of thinking. And that also helps us in structuring the implementation appropriately. However, you can see this arrow, this is still a bit one-sided. While developers now can introspect the way designers are working, the converse is still a black box. When reviewing the implementation, designers again still see the finished pages, not the building blocks. And this is where Storybook comes into play. So Storybook is a tool for building component libraries that is developer-focused but designer-friendly. And I think it's the perfect tool to bridge this gap in the other direction. Storybook is an interactive tool for visualizing UI components in an isolated environment. It comes batteries included for many frameworks like React, Vue, Angular, and many build systems like Vite and Webpack. It can be added to an existing project or can be used to build a design system from scratch. So let's have a tour and see what Storybook has in store. So Storybook comes with a front end to organize your components. These are organized as so-called stories that present the components, explain their variance in behavior, and let the user explore the interaction. This is an example instance that I've created specifically for this talk with some example stories based on plain material UI. So components are organized in these sections and folders on the left. And I've organized them in terms of the atomic design hierarchy. This is not necessary, but it is a rather common pattern. Each component comes with one or multiple variants. For example, here we have the primary button, secondary button, and a danger button. And each component also comes with an optional docs page that can explain the properties and the usage. So in which situation do you use the primary button? You should only use one per screen, for example. And with every story, you also get a code example that you can copy-paste. Those examples are interactive. They have all the hover and focus effects that the final component has. And if events are handled inside the component, you can interact with the component. In the canvas view, you also have some controls over the environment. So, for example, you can switch between dark and light mode. And you can select different viewport sizes. That's especially useful to check for more complex components, like a full screen, if they are, for example, properly displayed on mobile devices. This one isn't. Stories let you capture every state of a component in one place. Each story shows a specific variant, so for example, the primary button and the secondary button, with its properties, so you can document the entire component API visually. And by the way, this should be the Acme button here, not the plain button. Yeah, the code on the left is all it takes: a function to render the component and arguments that are passed to the component. So for developers, this makes it very easy to verify implementations visually without having to run the entire page. But also for designers, it is easy to compare the implementation with their designs visually directly on the component level. But you don't even have to create variants for every combination of properties. Controls allow the user to play around with the configuration of the component right in the Storybook front end. That's why we pass the props or the args. That's why we pass these args not directly here in the when calling the component, but rather as separate arguments. Storybook automatically inspects those arguments and generates the appropriate controls. Should scroll up a bit, or down. Here. Automatically generates those controls, mostly without any extra configuration. So the can you actually see that, or am I in the way of the slide? Okay, good. So the buttons, inputs, toggles, etc., are all auto-generated from the story I just showed you, and you can switch between, for example, primary, secondary text buttons here. You can change the, you can put it into disabled, so you can explore the disabled states. You can modify the text, or modify the color. Go to a, that doesn't work here? It does. So go to a success button or a error button. And yes, those are green and red, yay. So this is incredibly useful for exploring edge cases or different states without having to modify code. You don't have to make these changes in code, reload the page, and then see if it works and how it looks. You can just explore it directly here, live in Storybook. Wait, that. There we go. So sometimes you have custom types for properties, and you need more control over those controls. You can define archetypes to customize the control type and options. So for example, you can have radio buttons like we have for the primary, secondary, or text buttons. You can have drop-down selects like we had for the colors, and you have toggle switches like we had for disabled. But Storybook does not only help discovering and testing props, but also event handlers. the fn we're passing here is a spy that will register all events on that handler and will display them in the Actions tab here in Storybook. So, for example, with this input field, I can debug the onChange event, for example. And this can be incredibly useful to figure out when an event is triggered or why it's not triggered and how the exact event looks like. So you can inspect, if it's a more complex event, if it's an object here, then you can also inspect that. So no need to add the typical console log statement somewhere in your code running the page and debugging things. And if you need it, you can also pass another function here to fn that actually handles the event. So it's really a spy function. Storybook is not only great for exploring and testing components, but also for documenting them. Storybook supports Markdown with embedded JSX components, a format called MDX. And you can write rich and structured documentation with embedded Storybook stories or also other components like these color swatches here. And Storybook renders this to a beautiful documentation page, making it very easy to tell the story behind tokens and components. And it's also very useful for usage instructions and code examples. Thanks to Markdown, this kind of documentation can also easily be written collaboratively. So developers can provide the components, the implementation, and the structure of the page, and designers can add explanations, usage instructions, etc., which really facilitates the exchange. But you don't even need the fully fledged Markdown documentation. When you specify the autodocs tag, Storybook will just take any JSDoc comments and automatically create a page from these. So this makes it really easy to keep the documentation in sync with the code because it's directly generated from the original sources. Storybook also comes with a rich plugin system for all sorts of things. So, for example, accessibility tools, like to verify compatibility with different vision deficiencies, just as we saw. So you also have this blurred vision or different types of color blindness here. And, well, simple controls as, for example, switching between light and dark mode. Developers tend to work in their preferred mode. Some people prefer light mode, and some people prefer dark mode. And then you find something like this, because we just took the dark gray here in light mode and didn't care about the theme-aware, slightly muted text color. And there are more plugins, like, for example, for visual testing, for comparing components against screenshots. Just have to scroll down a bit. For comparing components against screenshots or to recognize visual regressions. And lots of other plugins like for interaction testing, for debugging, event handling, for user flows, etc. These are just a few examples, and there is a huge plugin collection listed on the Storybook website. So, how and when to use Storybook? there are basically two main options. You can add it to a front-end application as a tool for documenting the existing components and for helping team members to understand the components better. This is also very useful for visual testing. So during development, you can verify components in Storybook without having to spin up the entire application. But you can also run it as a standalone project. This is useful for creating self-documenting component libraries, for design systems that can be used across multiple applications. In this case, the components themselves are bundled as a library that can be used in frontends, and Storybook is kind of the touch point for exploring those components. Which approach to use highly depends on your use case. If you have a single front-end monorepository, or whether you have multiple front ends that already share some components. If in doubt, adding Storybook to an existing project probably is never wrong, and you can split off a component library later on anyway. If you're looking for inspiration, how to organize and document components, Storybook also hosts a list of showcases. Storybook instances from both open source projects and companies who make their corporate design available. And you have some pretty big names in there, like Airbnb, Grafana, Microsoft, GitHub, GitLab. Not all of them are available publicly, unfortunately. For some, you need to create an account, but plenty of them are public. So Storybook allows that collaborative two-way handover on all levels. Designers create the components individually. Developers can implement them on the component level in isolation. Designers can review the implementations right away and add documentation and usage guidelines. And once we are on the same page on this component level, we then can assemble them to full screens. But even in a screen-based handover, the guesswork and the reverse engineering here is gone now. Developers can break down the screen into components again and be sure that they do it in the same way as the designers intended. In fact, this also makes pixel-perfect screens a lot less relevant. Even wireframes are now absolutely sufficient for handover because developers now know what component and styling, for example, to use for a primary button, even if the primary button is only in a wireframe. So this is where the techniques and the tools come together. Atomic design gives us a shared language so that developers can understand the intent of designers and their way of structuring things. But Storybook gives us the shared workspace to also develop and review the components together, bottom up, in very quick and small iteration loops. And as an added bonus, I have also found that Storybook really helps thinking about cleaner front-end architecture. In order to be displayed and manipulated in Storybook, components must work independently to be testable in isolation. And this encourages or even enforces clear separation between presentation and business logic. So on one hand, you have the component and its internal state, like the selection state of a checkbox or the text content of an input field. And on the other hand, you have external controls of the state, like backend connectivity, validation, a global form state, etc. Because every component needs to be rendered in Storybook in a kind of sandboxed environment, we need to actively think about what is the internal state of the component and what is controlled from the outside. This encourages patterns like dependency injection, where, for example, data from the backend is passed as props rather than fetching it as part of the component. Yeah. So even organisms like a login form, for example, the naive way would be to just have a handler that performs the login and does all this stuff. Yeah, this works fine, but it does not allow for testing the login form independent from the backend. Plus, it comes with weirdly tight coupling here. Like, what is this URL here? Why is it part of the login form? A much better way is to inject the onLogin function via the props. Now, the architecture is much cleaner, and the component can be rendered independently. You just don't have to, well, you can just inject a spy here for the onLogin event. Storybook really encourages this architecture, and it also has some other benefits, like easier unit testing without having to constantly mock things. So let's bring all of this together. We talked about atomic design as a common language and Storybook as a tool for bidirectional collaboration. Let's see how this transforms the handover process. In the old process, each group, designers and developers, works in its own tech stack. Designers iterate in Figma or similar tools. Developers implement in their UI framework. The only handover is on the level of finished screens. Those are exported from Figma and then tested in the final implementation. So what happens in between on each side is a black box to the other side. By introducing a common language and shared tooling, we've transformed this into a collaborative process. The handover happens on all levels: design tokens, UI components, and finished pages. The black box becomes a white box. Developers implement atoms, molecules, and organisms in Storybook, and designers can review them on the same level, not just as part of finished screens. So we get a much tighter implementation review loop. And yes, there is some double bookkeeping. So you have still components in Figma and in Storybook, but pushing the double bookkeeping down from finished screens to individual atoms and molecules makes things much more manageable. So I would like to come back to the project we started with, our real-world examples, and talk about how it evolved. We took the button change incident as a warning shot, and we started to create a component library in Storybook. This also helped a lot when the company grew even further, and we eventually migrated to a micro-frontend approach, where each team, even backend teams, would create their own small front-end snippets, or organisms, which then were integrated into the page templates. So we basically democratized front-end development. However, after that, things took a turn. The client wanted to overhaul the entire design system. So they set up a team of designers whose only job was to create a comprehensive design system. And they took an entire year. During that time, work on the existing component library stalled. And both front-end developers and also the designers that were working on features rather than on the design system were constantly wondering which of their components would be deprecated or obsolete in a few months. So here's what you should avoid. Don't create a design system on the drawing board without involvement from developers. A design system should be either emergent, developing alongside with the feature design and implementation, or if you do want to do upfront design, involve developers right from the start to implement the components right away as they are designed. So suppose you're sold now and you want to start adding Storybook to your project on Monday. Where to start? Adding Storybook to an existing project is really easy. It will automatically detect the framework that you're using and generate the appropriate scaffolding. Then you can start adding stories for your components. Start small. Don't try to document the entire code base immediately. Begin with the smallest components and build from there. So let's finish with a quick recap. We investigated problems with full-screen handovers and as in the example of a button redesign that took way longer than expected. We introduced atomic design as a shared vocabulary between designers and developers to help bridging that gap and also talk about structure and hierarchy. We introduced Storybook as a tool that supports this more structured handover and allows designers and developers to build design systems collaboratively. And as a bonus, we saw that Storybook also benefits developers directly as it encourages cleaner and more testable architecture. Yeah, that's the end. Questions?
We have time for 1 or 2 questions. So, start with you. Yeah, you.
So, you said we should have it done differently. So, like for me, it looks like developer chose perfect abstraction for the set of features that arrived to them before that, and then feature arrived that required them to like change the whole abstraction. Yeah. And like if I understand, like later another feature arrived, like from top down, like change the design system that requires them to change abstraction again. So you can mathematically pick a sequence of features that every new feature will require to change abstraction, like totally rewrite. So how does like using Storybook and this whole approach address these problems specifically?
Usually you don't have a specific feature that changes the approach. You have a set of rules and best practices that designers usually apply and that they base their designs on. So the change was not because there was a new feature that surprised the developers. The problem was that there was a different way of working between developers and designers, and the small change in design was a big change in the implementation.
One quick one.
Okay, so I think what you presented is a very mature solution in a particular space, but I think it touches on something very important, actually, that any software development is a series of convergent conversations with multiple expressions of which the programming produces one output. So in that sense, and particularly now that people like designers are getting more used to working with tools like AI and being more directly involved in that conversation, this view, this kind of language-oriented development, I have this feeling that it might be actually a really key thing in the future.
Yes.
To find ways of expressing that conversation textually, reproducibly, that people directly can use. Is this a pathway there? Or is it, because I worry that it's too bound into particular solutions like React or...
One thing that I'm observing is that designers and also product managers do a lot more implementations themselves. You can use tools like Claude to just create a mockup, so you don't do the mockup in Figma and connect all the dots for a click dummy. You just create a very small toy application in actual code. So yeah, that changes the handover process a lot, but you always have to decide, is this code then, is it throwaway code or is it something that we maybe can already use? But yeah, that changes the conversation as well.